Up to now, I have talked quite generally about where quantum mechanics fits into the scheme of mechanics. The underlying theme is that quantum mechanics is incomplete from a philosophical point of view, from a physical point of view, and if you believe EPR, from a mathematical point of view. Physically, quantum mechanics predicts most properties of matter and is the most successful theory we have about the microscopic. However, in some cases, it gives nonsense results, such as the persistence of entanglement to separated particles, non-locality, and these new quantum anomalies. So in the next few entries of this blog, I'm going to be more technical and discuss my new subquantum theory. The title of the talk is Anomalies in Coincident Probabilities in EPR Data. But first, a preamble to set the stage. I gave a short 15-minute version of this talk in Torino, Italy in May of 2010, and a 30-minute talk in Torun, Poland, the birthplace of Nicholas Copernicus. Notice that the theme of the conference is quantum channels and quantum information theory. Now, one of the consequences of a subquantum theory I presented at these meetings is that quantum channels do not exist. Entanglement is a property of quantum mechanics and not of nature, and the Bell's theorem is repudiated. In 2009, I also attended a meeting in Toronto, and at that meeting, the first John Stuart Bell Prize for work in quantum information was given to Nicolas Giazin from the University of Geneva. In his talk, he made a profound and far-reaching statement. The whole of quantum information theory rests upon the validity of Bell's theorem. So what are quantum channels and what is Bell's theorem? In 1993, Bennett, Brassard, Crapeau, Jossa, Perez, and Wouters wrote the classic paper on teleportation. The title is Teleporting an Unknown Quantum State via Dual Classical and Einstein-Podolsky-Rosen Channels. Now, by classical channels, they mean just calling on the telephone. However, Einstein-Podolsky-Rosen channels refer to the paper of 1935 called EPR, and these are the quantum channels. It is certainly my contention that experimental data cannot support the notion of quantum channels. They also cannot be supported on the basis of physical intuition. Einstein, Podolsky, and Rosen actually ruled out such connectivity in their 1935 paper. Let's have a look. Here it is. Can quantum mechanical description of physical reality be considered complete? It's worth reading a few of their points. A sufficient condition for the reality of a physical quantity is the possibility of predicting it with certainty without disturbing the system. And then, any serious consideration of a physical theory must take into account the distinction between the objective reality, which is independent of any theory, and the physical concepts with which the theory operates. Please note, independent of any theory. And to emphasize that everything is local, that is, there are no quantum channels, they state, if, without in any way disturbing a system, we can predict with certainty, that is, with probability equal to unity, the value of a physical quantity, then there exists an element of physical reality corresponding to this physical quantity. This is one of the most quoted sections of the paper. Nonetheless, quantum channels are insensately conjectured to be responsible for conservation of angular momentum between a pair of separated and entangled spins. What this means is that no matter how far the entangled pair is apart, if one is flipped, the other must flop, with the connectivity between these particles given by quantum channels. The quantum channels are supposed to mediate non-locality. Many people believe that quantum mechanics itself is non-local. Here we find that non-locality is one of the most striking properties of quantum mechanics. Two distant observers, each holding half of an entangled quantum state and performing appropriate measurements, share correlations which are non-local. They are talking again about quantum channels mediating non-locality. But what is half a quantum state? I defy anyone to write down half an entangled state from quantum mechanics. According to David Bohm, an entangled state is an undivided whole. The speed that information is communicated over quantum channels has been calculated, and it is fast. Here we see. We set the lower bound for the speed of quantum information in this frame at 150,000 times the speed of light. We need tachyons for that. This made it to the journals like Scientific American. Quantum weirdness wins again. Entanglement clocks in at 10,000 times plus faster than light. What is quantum weirdness? Books have been written to try to rationalize quantum mechanics and relativity with mixed reviews. You often hear the statement, quantum mechanics and relativity live in peaceful coexistence. Well, it is not true. Let's put tachyons aside and just accept that believing the connectivity between separated entangled particles means just the opposite. Quantum mechanics is in conflict with relativity. There's another alternative, of course. There is nothing incompatible between quantum mechanics and relativity at all, but rather quantum mechanics is an incomplete local theory, and the long-range correlations have an origin which is local. Let's turn to